In this section, we're going to be measuring angles. So let's look at some key concepts about angles. An angle is formed by two rays with the same endpoint. So let's look at what this would look like. Here we have the ray AB. And we have the ray AC. These two rays share the same endpoint of point A and therefore form an angle. The rays are the sides of the angle. The endpoint is the vertex. So in this example, A would be the vertex, and AB and AC would be the sides of the angle. Now we're going to look at an example of naming angles. Here we have the angle JML. And we want to have two different names for this angle, or for at least angle 1, which is the top half. So we can see that J, M, and K make up angle 1. So one name would be angle JMK, and then another name would be angle KMJ. Now we're going to look at some key concepts about different types of angles. So the first angle we have is an acute angle. When we have an acute angle, the degree measure of that angle has to be greater than 0 but less than 90 degrees. So here you can see we have an acute angle because the degree measure is somewhere between 0 and 90 degrees. Now a right angle has a degree measure of 90 degrees exactly, so it has to equal 90. And usually there'll be a little box in the corner that indicates that it is a right angle. Now an obtuse angle has to be greater than 90 but less than 180 degrees. So in this angle you can see that it's somewhere between 90 and 180. And then straight angle has to equal 180, and it's basically just a straight line. When measuring angles, you can use a protractor in order to figure out the different angle measures. And using that angle measure, you can identify whether it's acute, right, obtuse, or a straight angle. Now we're going to look at different types of angles. Angles with the same measure are congruent angles. Angles with the same measure are congruent angles. So this means that if measure of angle A equals measure of angle B, then angle A is congruent to angle B. You can also say that if angle A is congruent to angle B, then measure of angle A equals measure of angle B. So here you can see that we have two angles, angle A and angle B. And if their measures are equal, that means they're congruent. And if they're congruent, that means their measures are equal. Now we're going to look at the angle addition postulate. If point B is in the interior of angle AOC, then the measure of angle AOB plus measure of angle BOC equals measure of angle AOC. So you can see the diagram that we have here. Angle AOB plus angle BOC is going to add up to equal the measure of angle AOC. So the two separate parts would add up to equal the measure of the entire larger angle, which is AOC. Now we're going to look at an example of this that requires us to use the angle addition postulate. The information we are given is if the measure of angle RQT equals 155, what is the measure of angle RQS and the measure of angle TQS? So in our diagram, we can see that we have angles RQT, which is made up of angle RQS and SQT. So based on the angle addition postulate, we know that the measure of angle RQS plus the measure of angle TQS equals the measure of angle RQT. Now we can go ahead and substitute in values. The measure of angle TQS equals 3x plus 14. The measure of angle RQS equals 4x minus 20, which equals the angle RQT, which equals 155. And this is all information that we have been given from the problem. Now we can go ahead and combine like terms. 4x plus 3x equals 7x. Negative 20 plus 14 equals negative 6 equals 155, which was on the right side. Now we can go ahead and isolate the 7x, so we have to add 6 to both sides. And when we add 6 to both sides, we are left with 7x equals 161. So we want to isolate the x, so divide both sides by 7, which leaves us with x equals 23. So now that we know what x equals, we can go ahead and substitute 23 in for both the x's in the top equations. So let's start with the measure of angle RQS. So 4x minus 20. So we substitute in x, and we get 4 times 23 minus 20, which equals 92 minus 20, which equals 72. So that's the measure of angle RQS. The measure of angle TQS, which was 3x plus 14. So we substitute in 23 for the x. We get 3 times 23 plus 14. And when we simplify, we get 69 plus 14. And when we simplify further, equals 83. So measure of angle TQS equals 83. Now we're going to look at a final concept for this section. When we have an angle, the degree measure on the inside of that angle is called the interior of the angle, and the area on the outside is called the exterior. All angles have both an interior angle and an exterior angle.